Hello guys, in this video we are going to learn about the behavior of oxidation of alcohols. First of all, we have to learn about what are primary alcohols, secondary alcohols and tertiary alcohols. Initially we have to consider about primary alcohols. Primary alcohols comprises with one alkyl group and two hydrogen groups and one OH group. Also, this alkyl group can be methyl group or ethyl group or any other alkyl group. Also, this R can be benzene. Let's consider about secondary alcohols. Secondary alcohol comprises with two R groups, one OH group and one hydrogen atom. This R group can be similar or differ. This R can be CH3, C2H5 or any other alkyl group as primary alcohols. Let's consider about tertiary alcohols. Tertiary alcohols have three R groups like this: R1, R2 and R3 and one OH group. This R1, R2 and R3 can be methyl, ethyl or any other alkyl group including benzene. Now we are going to consider about oxidation reactions of alcohol. Firstly, we have to use a primary alcohol. This primary alcohol is known as methanol. This primary alcohol is known as ethanol because it has two carbon atoms and the carbon chain becomes eth, so this becomes ethanol. In this oxidation reaction, we have to use acidic potassium permanganate as the oxidant. Now I separately draw this molecule to show you the mechanism of this reaction. We know that the electronegativity of carbon is 2.55 and electronegativity of hydrogen becomes 2.2. So electronegativity of carbon is greater than the electronegativity value of hydrogen. So carbon absorbs electron from this hydrogen. Also there is the same reaction like this. So there is a electronegativity difference about 0.3 between carbon and hydrogen atom. Because of this electronegativity of carbon and hydrogen, we have to replace this hydrogen with OH group. After replacing hydrogen with OH group, we can see there are three OH group surrounding this middle carbon atom. So now we know that when one carbon has more than two OH groups, it becomes unstable. So we have to remove one H2O molecule like this. After removing one H2O molecule, we can get our final product like this. This becomes a carboxylic acid. This is known as acetic acid. Now consider about a secondary alcohol. This has two CH3 groups, so we have to use our same oxidant, acidic potassium permanganate, and we need to get the final product of this reaction. First of all, as previous mechanism and previous steps, we have to replace this hydrogen atom with OH group because there is a electronegativity difference between carbon and hydrogen. After replacing this hydrogen, there is a OH group instead this hydrogen. Now you can see there are two OH groups, so this carbon atom becomes unstable, so we have to use our previous steps. Then we need to remove one H2O molecule like this. After removing one H2O molecule, we can get a ketone. Also, we know that ketones cannot be oxidated anymore. Our final product of this chemical reaction becomes propanol. As the final alcohol, we have to use a tertiary alcohol. This is our tertiary alcohol. It has 3 CH3 groups. So we have to use the same oxidant, acidic potassium permanganate. Then we need to find the final product of this reaction. According to our mechanism, there is no hydrogen atoms surrounding this middle carbon atom, so we can't oxidate this tertiary alcohol. As an exercise, you have to oxidate this alcohol. This comprises with primary, secondary and tertiary alcohol. And pause the video, do it to practice for this mechanism. We have to use the same oxidant, acidic potassium permanganate. Initially we need to identify all three types of alcohols including this chemical formula. So this carbon becomes secondary alcohol because this carbon has 2 R groups, and this carbon becomes tertiary alcohol and this carbon becomes primary alcohol. Now we know that only secondary and primary alcohols can be oxidated, but tertiary alcohols cannot be oxidated because it has 0 hydrogen atoms surrounding the carbon which is fixing with the OH group. So the final product of this chemical reaction should be like this. CH3 group cannot be changed. This OH group becomes a ketone, and this is the final product of this reaction. As I mentioned previously, this carbon becomes ketone and this carbon will not change. This group also will not be changed. This group becomes a carboxylic group. As a summary, primary alcohols becomes carboxylic acid when using acidic potassium permanganate like this RCOOH. This is a carboxylic acid. Also secondary alcohols, I takes R1 and R2 OH. This is a normal formula of secondary alcohols. We have to use acidic potassium permanganate and that becomes ketone. Also finally, tertiary alcohols cannot be oxidated because you know the mechanism of this reaction now. So you have to keep remembering any tertiary alcohol cannot be oxidated using acidic potassium permanganate. In my next video, I will teach you a very short trick to identify the behavior of alkyl benzene with oxidation reactions.